Okay, so we are starting with equations today, and we are going to learn how to solve for the variable and figure out what is missing in each problem. The first thing you want to do is the review at the bottom of page 401. The directions say, rewrite each number as an addition, subtraction, multiplication, or division expression. And you can use the operation only once. So how many operations did they tell you? 4. How many numbers do you have? 4. So you're only using them one time. So if you use an addition problem here, you're not going to use it for the other 3. Does that make sense? So as an example, what expression could I use to make 24?
6 times 4.
6 times 4. And notice it says expression, so I don't have an equal sign or an answer. Does that make sense? So now that we've already used a multiplication problem for number 1, you need to find an addition problem, a subtraction problem, and a division problem for one of the other 3. Any questions? All right, I'm giving you about 2 to 3 minutes to do this. Go for it. All right, since we've already used multiplication, we can't use it again. Who can tell me an expression to make 1/2?
1 minus 1/2.
1 whole minus 1/2. Yes? All right, now I need an addition or division problem for 0.
50, 50, 100. Okay. We'll do it.
0.
We'll do it. Oh. 0 divided by 0.
No, you can't divide by 0.
0 divided by 8.
You can't divide with 0. Okay, let me rephrase. We need an addition problem for 0. There we go. And we need a division problem for 100. That would be 10. How about 3,600 divided by 36? That would work.
What 200 divided by 2? Yes.
Helen. All right, guys, let's look at the next page. All right, this is very much like the review we just did. We're going to find problems that equal these answers. So it says, write 3 different expressions to equal 4. So who can tell me an expression that will equal 4? You.
Oh, 1 plus 3.
1 plus 3. All right, who can tell me another one?
2 plus 2.
Mhm. How about not an addition problem? 2 times 2. Okay, all of those equal 4. Are those the only problems that would equal 4? No, there are many different problems that will equal 4, and that's one thing you will learn during this lesson. There are many different ways to solve the problem. Does that make sense? Okay. For number 2, we're doing the same thing. We're writing 3 expressions that are equal to 4 plus 5. Well, what is 4 plus 5 equal? 9. So we're not putting 9 in the blank. You're telling me another problem that will equal 9.
6 plus 3.
6 plus 3.
5 plus 8 plus 4.
Without using the 4 and the 5.
18 divided by
18 divided by 2. I'm glad we're getting away from addition. And
3 divided by 2.
3.
5.
There we go. Any questions about those? Does each side equal itself? Yes. So number 3, if we look at our expressions from number 1 and number 2, what can I do to my number 1 expressions to equal my number 2 expression? What can I do to these problems to equal these problems? What do I know about my number 2 expressions? Both sides equal 9. What do my number 1s equal right now?
4.
4. So how can I make them equal 9?
Add 5.
We're going to add 5 to both sides. If I only do it to one side, is it true? No. That is why I have to do it to both sides. Does that make sense?
Yes.
That equal sign means it has to be equal in front and in back. So what did we do to our number ones to equal our number twos?
We added 5 on both sides.
Add 5 to both sides of the equation. Any questions about that? That's going to be a big thing in today's lesson, making both sides equal. Okay? All right, once you have that written, you can look at the next page.
And this one, we're going to start looking at substitution to help us understand the equalities. Remember, and this goes back to definitions from last chapter, actually. An equation is a statement of equality between two expressions. They can contain numbers, variables, or both in the same mathematical sentence. What is the key difference between an expression and an equation? See? Excellent. That equal sign is that different. Okay? So if I have the equation, and we know it's an equation because it has the equal sign, a plus 4 equals something plus 5, we have an unknown number here, right? A lot of times we'll use a variable. We can also use a blank to show it. Right now, we're going to start with the blanks. Later on, we'll get back into the variables. One way to determine the unknown number is to rewrite the expressions on both sides of the equal sign until they match. There's 3 different examples here of students who are trying to figure this out and see which way they can figure out how to figure out what goes in that blank. Able?
Did you use a space instead of a variable in the algebra expression?
Technically, yes, but it's a lot easier if you use a variable. Riley says the equal sign tells me to perform the operation on the left of the equation, figure out what it equals. So she said a plus 4 is 12. And I said, okay, well, I'll put that in the blank, then 12 plus 5 is 17. So the unknown number is 17. Does that make sense? I hope not, because they told you it's wrong. Okay? Says I can determine the unknown quantity by rewriting both expressions. That's one of the things we want you to get used to today. So she started and said, okay, it's plus 5, but I can rewrite that as 1 plus 4, right? That's still 5? Yes? Okay? So on this side, I have the 4 from my original equation. And I've now changed this to 1 plus 4. So she then says, okay, well, I can now take that 8 and break it down to 7 plus 1, correct? So we agree that 7 plus 1 is 8?
Yes.
Yes? Okay? So now that I've done that, now I have a 1 plus 4 on this side and a 1 plus 4 on this side. So the only difference is my blank, which is 7. Yes?
I already put the answer down.
It's called showing what's in your head.
Can you understand what she did?
Yep. Looks like you got one right now.
Good. Does this make sense? Okay? So all Fiona did was she took the second side and broke it down to a number that was on the other side, a 4, and then figured out how to make the other number part of it to get the same thing on both sides. Clover says the equal sign means that the expressions on each side have the same value. I can take 1 from the 8 and give it to the 4 and keep the value of the expression the same. She said, okay, I have 5 on this side, I had a 4 on this side, so I'm going to take a 1 away from the 8 and add it to the 4 so that I can get my 5 here. Does that make sense? Okay, here's the key. She added 1 and subtracted 1 on the same side of the equation. If I have 1 and I take 1 away, what have I got?
None.
0, right? So what she's done is effectively she hasn't changed the equation at all. Because I can add 0 to any number and I get that number, right? So 12 plus 0 would be 4 plus 0 would be
4.
so it doesn't matter what the number is. If I add 0 to it, I don't change it, correct? So that's all she's doing is saying, what I added here, I took away here. So I've kept this side of the equation the same. Because it's just now adding 0. What's 8 minus 1? 7. So that's where the 7 comes from. She did 4 plus 1 to get the 5. So now has this. Meaning my blank is what?
7.
Does that make sense?
Uh-huh.
Okay? Guys, all we're doing is manipulating the numbers, just like we did at the start of the exercises today, to say, how can I make the two sides look alike? Okay? Because here's your first definition for your new vocab sheet. We have what we call the reflexive property of equality. The reflexive property of equality states that a number is always equal to itself. Might sound kind of silly, but it's actually one of the basics of mathematics. We're saying if I have A equals A, I've actually got my solution. When both sides of an equation look exactly the same, their values are equal.
Oh my god.
So literally all we're doing is breaking these numbers down so that we make both sides of our equation look the same. This is one of the methods we can use to be able to solve our equation. Let's go to our next page. So on this one, what is the unknown number in the equation 8 plus 4 equals something plus 5?
7.
What did we just determine?
7.
7. How do we get there?
I know. We do a clever there. We just took 1 from 8 to make 8, 7, and 4, 5.
Okay.
Since you need to
We
find,
take 1 from the 8 and add 1 to the 4,
right? And then
correct?
equals,
Something plus 5.
yeah. And
So we now have 7
plus
plus
5
5 equals
blank.
plus 5. Since those are identical, means we just put our 7 here, and we get our solution.
Right, you should be writing this down.
So why does this make sense? What did we just teach you? What was the new vocab we gave you?
Reflexity property of equality.
Okay. So the reflexive property of equality shows when both sides look the same, they are equal. So all we did was rearrange the numbers to make both sides look the same. Does it make sense for you now?
Yes.
Okay. So we already talked about it real quickly. Let's put it in writing. We looked at Riley's reasoning. What did she do wrong?
She just kept on going. She thought it was a full equation, not a comparison.
Okay. I like the way you started your statement. You kind of flubbed at the end. But basically, what you were saying was she treated it like one expression, not an equation, right? Meaning to change, she basically ignored the equal sign. Rather than adding up on one side and getting the other side to look like it, she just put that value in the other side. You can't do that. You can't just ignore the equal sign.
I don't think that's how it's supposed to happen.
Yeah, it's not an H, that's what you're thinking.
Imagine.
That is F-I-G-N. That's how you spell fine. Power Fiora's reasoning and Clover's reasoning is similar. What did they do that was alike?
They distributed the numbers.
Good. They both broke the numbers down to make them look the same on each side. Okay? So they both broke them down so that I would get the same numbers on both sides of the equation. What did they do differently? How did they change in how they did it? Everyone's answering everything today. Let's give someone else a chance. What did they do different? You have to look, turn the page and look at it. Sammy? Okay. Fiona just used addition. She actually broke it down to add that same amount to both sides. So Fiona used addition. But who's the other one? Clover used addition and subtraction. But really, they did the same thing. They were just making the sides look alike by breaking the numbers down. They're making sense so far.
Yes.
Okay? So what we're trying to get you to understand that reflexive property of equality is really what we're shooting for. I want both sides of my equation to look the same. How we do it is up to you. We're giving you a lot of different tools. There's a lot of correct answers to everything that we're doing today. But most of you should get to the point where you're kind of looking at them the same way. So let's continue working now. So now we're going to just start you off with an equation. If I have an equation, 31 plus 67 equals something plus 12, I want you to determine the unknown number by rewriting the expressions on either side of the equal sign until they match. So that's your goal. You're going to rewrite it, change the numbers around till you get the same things on both sides of your equation. How did you use reasoning to determine your unknown? And then how can you check your answer? We're going to give you guys about 5 minutes to work problem 4, all 3 sections. You may talk as an entire table. We want you guys to engage with each other on this one. We got 5 minutes. Go ahead and start. I'm going to just do what they did before. The whole idea is I need to get a plus 12 over on this side of my equation, right? So I take either one of the numbers they give me, 31 or 67, and break it down to something plus 12. So I'm going to do the 67 because to me that was easier. So I rewrite anything I haven't done. So it's 31. To get to 67, I'm going to do 55 plus 12. Everybody agree that 55 plus 12 is 67? Yeah. So we've got the same piece now, right? I now have a plus 12 on both sides, don't I?
Oh my gosh.
Well, it did. Mr. Champ, we stopped doing that. Before we distract you for the kids. So now I put these 2 pieces together. What's 31 plus 55? That's going to give me
86.
86 plus 12 equals something plus 12. Well, now these pieces that are the same, meaning this just goes right here.
Wow, I did so. I mean, I did leave something really different.
That makes sense.
I didn't know.
Okay. So how did I use reasoning to determine the unknown value? I broke 67 into 55 plus 12. So I could use the reflexive property of equality.
Wait, how am I supposed to write it if I did 31 minus 19 plus 67 plus 19? That still gave me 86.
Both sides of my equation now look the same, right?
Can you check my book?
You just did the other way.
Okay, but how would I do that?
You'd still use reflexive property. So it's, you added and subtracted 19 from each.
Okay, so I brought 31 into 31 minus 19.
Yep, because you got this down to 12. You just change this one to 12. It's the same thing. Now, here's the big one. How can I check my answer, guys? Mabel?
Add both sides. But not together, just like
Close.
you just add 31 plus 67, and then you the other side, and then you do 86 plus 12, and then find a 30.
So you said it, but you didn't use the math terms. I don't put it, I substitute 86 into the other side, right? So I take 31 plus 67, and I get 98. Then I take 86 plus 12, and I get 98. Does 98 equal 98? Yeah. What did I do? Substitute my value in and check. Make sure both sides are equal. Just did on this page. So Gabriel changed the 31 to 12. He took 19 away from the 31 and added 19 to the 55. But he still ended up with the same exact concept. His numbers just looked a little different because he started with 12 plus 86 and then got it on the same on the other way. 5 from 67.
So you'll be left with 12, and then you add the 55 to 31. That will get, yeah.
So you just use the Clover's method.
Yeah.
And again, guys, you can use the methods. Any of these methods will work. Okay, plot your highlighter.
What's the bottom part? You skipped it.
So I go back. I forgot a very important one at the bottom down here. Here's 2 more chances for you guys to show that you can get that. You got 2 minutes. So there are multiple ways to do this. So front, I'm just going to show you a couple ways based on the strategies that were shown to you earlier. First thing I know, I need to get something plus 60 on the left side of my equation. So for me, I'm going to take the 85. That makes it pretty easy. I know the 85 I can rewrite as 60 plus 25. Correct? That's still 85. Plus 45 equals something plus 60. I now have my plus 60 parts on both sides. So I'm going to put these two together. Gives me 60 plus 70 equals something plus 60. So I know that the 70 goes in right here. Now we can verify, so I'm going to check it. I'm going to go 85 plus 45. That's going to give me 10, 130. Then I'm going to do the other side, 60 plus 70, 0, 130. Does 130 equal 130?
Yes.
Check. So I know I did it correctly.
No.
Make sense?
Yes.
Now, this one, I actually am going to use the other method, Clover's method. I'm going to subtract and then add the same thing. Because to me, when I look, I saw 9 and 14. Those are pretty easy to get to, right? I just do 9 plus 5. But that means I have to take away 5 from the 23 in order to keep my expression and my equation equal.
Wait.
So I now have 2 parts here. 9 plus 5 is going to give me 14. Plus 25 minus 3 is going to give me 18. I said 3, but I meant 23 plus minus 5 gives me 18. So I now have my plus 14 on both sides. My blank is going to be 18. Let's go back to our original and check it. 9 plus 23 gives me 1232. 18 plus 14 gives me 1232. Does 32 equal 32? Yes. So again, there's lots of ways to get the correct answer. Choose one that works for you. Okay, now we'll go to the next page and start on our vocab. Watch your highlighters. These, write down. These properties are ones you are going to use for the next 5 years at least. Good. Start to get to understand them. The first is your addition property of equality. It states that if 2 values, A and B, are equal, when you add the same value C to each, the sums are equal. The subtraction property of equality is basically the same. All the changes is our operation we're using? But when I subtract the same value C from equal values A and B, the differences are equal. The way I like to think of it, to put it in kind of plain terms, if I add the same thing to both sides, it stays the same. Or if I subtract the same number to both sides, it stays the same. Okay? So here it is written algebraically. If A equals B, then I can say, okay, if I add C to both sides, it's still equal. Or if A equals B, then if I subtract C from both sides, it stays equal. Pretty easy, right? We can also think about this as a double number line. When we are getting a double number line, we can find a solution. Solution to any equation is any value that makes the equation true. So that's what we're trying to do now, is make make it true. So if I do a double number line, or an equation, x equals 15, on my double number line, one is going to be my numbers, so I have my 0 and my 15. The other side is going to be my variable, so I'm going to have 0 down here as well, and x. I show my solution by making it into a dumbbell, showing that those numbers are directly across from each other. Does that make sense so far? Can everybody understand how this double number line represents this equation of x equals 15? Anybody not see it? Okay? So now we're going to use the property of equality stated to write at least 3 equations with the same solution. Represent each equation on the double number line. So we got 2 parts. We need to write at least 3 equations and represent them. So we're going to do the addition property of equality, meaning I'm going to add the same thing to both. So give me a number between 1 and 10. 7. We'll go with 7. So using my base of x equals 15, the addition property of equality says if I add 7 to both sides, x plus 7 equals 15 plus 7, it now remains equal. So what's 15 plus 7?
22.
22. So there's my first one. So I'm now to graph this. I'm now going to go to x plus 7. And above it is going to be 22.
Remember how we did on the review at the beginning and we said we added 5 to both sides? That would equal the second number 2 equations? 9? That's what you're doing here. Make sense?
Yeah.
So give me another number between 1 and 10.
8. 4.
8. So I can say x plus 8 equals 15 plus 8. What does 15 plus 8 equal?
Now you can say it.
23. So I can now do another one just below this, x plus 8. And right above it is 23. Okay? Supposed to do a third one, but because we're running out of time, we're going to go to the next page. How can I do this with subtraction? Again, I'm going to show you, we had it started at x equals 15. Exactly. So give me a number between 1 and 10. 7. So x minus 7 equals 15 minus 7. Subtract by the equality. I take the same number away. X minus 7 equals 8. So I can go back to my number line. And I say, okay, well, x minus 7 is 8. Does that make sense? Does it matter if I added or subtracted? No? Okay, so just to help you guys understand, it doesn't matter if I start at my solution. Last time I started you at x equals 15, right? This time I'm going to start you at x plus 5 equals 10. But we can do the same thing. Using addition property of equality, x plus 5 equals 10. Give me a number between 1 and 10, Ryan. 6. So if I add 6 to both sides, Now, remember how we combined like terms? I now have 6 and 5 together, right? So that gives me what? X plus, what's 6 plus 5?
11.
11. What's 10 plus 6? 16. So I can now rewrite this as x plus 11, and my solution is going to be 16. Does that make sense?
Yes. Did you say?
We can do the same thing on subtraction, right? If I start at x plus 5 equals 10, give me a number between 1 and 4. 2. Let's subtract 2. So I'm going to do x plus 5 minus 2 equals 10 minus 2. What's 5 minus 2?
3.
X plus 3 equals, what's 10 minus 2? 8. So I can go down here, x plus 3 equals 8. There's a subtraction solution. Does that make sense?
No.
Why not?
Why did you put x? Why did you say x plus 3 and put x plus 3 when it's x plus?
Because what's 5 minus 2?
8.
I can buy like terms, right?
No.
Okay. So our next page, we have a couple more definitions for you.
Number 5 and 6 on your you guys.
These are just like the ones we just did, but we're going to add 2 more operations. It's the multiplication property of equality. States the 2 values A and B are equal. When you multiply each side by the same value, see the products are equal. And division. When you divide equal values by A and B by the same value C, the quotients are equal. Now, there is a caveat on this one. C cannot be equal to 0. Mathematically, we have not yet determined how to take something and divide it into nothing. Let's mathematically figure that out. That's going to be like one of our next major advances in math. But so far, no one's been able to figure it out. How to take something and make it nothing. Doesn't work. Yeah, okay. 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 So we're gonna do that same thing we just did, but now we use multiplication property of equality. Right now I know that x equals 5, right? But if I multiply both sides by 2, 2x equals 5 times 2. What's 5 times 2? 10. So 2x equals 10. So down here I would put 2x. Up here I would put 10. And we draw the barbell to make sure Mr. Chan stays happy and understands that those are directly related.
Interesting.
Are we good on that? Does it make sense? Okay. Let's go ahead and go to page 411 real quick. There's your work space.
Okay.
This is your homework, 411. Put up, please. On this one, this should be one of the easiest journal entries ever. This is literally just the definition, guys. Fill in the proper terms. Your homework, determine each unknown value. Did it say how you have to do it? No. So show your work as much as possible. You should be checking your answers. Show us to check so that we see that you understood how those go together. Turn the page over. Here's the one that everybody's going to mess up if you're going to mess up the homework today. If I have the equation x equals 12 on the double number line, I need to use the property of equality stated to write at least 3 equations. How many do I need?
3.
What else do I need to do? Represent them on the double number line. So there's 2 tasks. There's 2 tasks, 2 properties. I need 3 for each. So I should have 6 new equations represented on this number line. Make sense? So I need to do 3 for addition and 3 for division.
When they say least, that means that you can do more.
You can do more, but we need at least 3. They did give me a good number in 12 to divide. So remember, I've got a lot of factors of 12 I can divide by. You only have to do 3 of them. Questions on your homework? Guys, your biggest thing, make sure you do 3 of each for each of those properties on that back page.
Don't worry, I made it very clear.
Okay?
3 each.
Good luck, guys.
I